All right, if you're a new grad just hitting the field, listen up. Welcome. I want to talk about your first real test out here. And no, it's not about flowing a well. It's about mastering the detailed, meticulous prep work that makes everything else safe and possible. So today, we're going to dive deep into one of the most critical pieces of that prep.
So let me ask you a question. Just picture the rig in your mind. What do you think is the single most dangerous piece of equipment we work with? Is it the top drive? The iron roughneck? Maybe the high pressure lines? You know the answer. It's probably not what you'd expect.
Because so often, the real danger lies in the component you just take for granted, the one you walk by every day. And today, we are zeroing in on a perfect example of that, the King Post. It is the absolute backbone of your boom system, and getting the prep right on this thing, well, it's completely non-negotiable.
Okay, so why all the fuss? Look, this single piece of steel is the linchpin for your entire lifting operation. It's holding up the boom, the burner. We're talking literally tons of equipment hanging off of this thing. If it fails, the consequences aren't just bad. They are immediate and they are severe.
And hey, don't just take my word for it. This right here, this is pulled directly from our Field Safety Handbook. The official severity rating for a King Post failure is catastrophic. That word means something. It means loss of million-dollar assets, it means serious environmental damage, and most importantly, it means people can get seriously hurt, or worse. This is exactly why we obsess over every single detail.
So where do we even begin? I know your first instinct as a new engineer is to get out there, get your hands on the steel, and start inspecting. But that's a mistake. Your first line of defense, your very first check, is always, and I mean always, the paperwork. First thing you're looking for is the Certificate of Conformity, what we call the COC. The easiest way to think about this, it's the equipment's birth certificate. It is the official, signed-off proof that this King Post was built exactly to the approved engineering design. If you can't find the COC, it's a full stop, no go.
And right alongside that, you need the Quality Control Plan, or QCP. Now, if the COC is the birth certificate, think of the QCP as its entire medical history. This document details every single test, every inspection, every material trace, and every weld report from the day it was made. This paper trail is what proves its integrity from day one.
So, this becomes your non-negotiable checklist. Before you even think about rigging this thing up, you've got to be able to answer yes to all four of these questions. Do you have the COC? Check. Have there been any modifications? Is the QCP available and complete? And are any and all repairs properly documented? This right here is your job as an engineer. You have to verify the asset's history before it has a future on your job site.
Okay, so once and only once the paperwork is verified, then you can get your hands on the steel. Now it's time for the physical exam, and you really need to have a sharp eye for what to look for.
Now you've got to put on your detective hat. You start with the pie eyes. Those are the connection points for all your rigging. Are they bent, worn, or damaged? Then you need to meticulously scan every single inch of the welds. Look for hairline cracks. Search for any signs of unauthorized, undocumented repairs. You know, a weld that looks newer than the others or it just doesn't look right. And always check for damage that might have happened just getting it to the location.
And here is a pro tip that will serve you well your entire career. If you see something and you're not 100% sure, don't guess, don't ask your buddy. You go find the operating and maintenance manual. That book is your single source of truth. Refer to it every single time.
You have to remember, a King Post is only as strong as its connections. It doesn't matter how solid that piece of steel is if the things holding it in place are weak. So now, we're going to focus on the guy lines, the support cables, and the clamps that hold it all together. This is where tiny details can make a gigantic difference.
In fact, there is one simple phrase, a little memory aid, that is probably the most important thing you will ever learn about making these connections. It's been passed down for generations of rig hands for one very good reason. It works.
And that phrase is, never saddle a dead horse. It's simple, it's memorable, and it will stop you from rigging a U-clamp incorrectly. Why does that matter? Because rigging it backwards can reduce the rope's breaking strength by a catastrophic amount.
So, what does it actually mean? Let's break it down. The dead horse is the dead end of the rope, the short tail that isn't taking the load. The U-bolt, the U part, goes over that dead end. The saddle, which is the part that actually grips the rope, always goes on the live, load-bearing end of the rope. Simple, right? You saddle the live horse, never the dead one. Now, getting the clamp on correctly is only half the battle. This isn't about just cranking on it until it feels tight. It is about making it right. This table, this is straight from the handbook. It shows you the exact torque specs. You can see right there, for a 1-inch rope, you need to hit exactly 225 pound-feet of torque. You don't guess. You use a calibrated torque wrench, and you hit these numbers precisely. In this industry, precision is safety.
All right, we've checked the papers, we've inspected the steel, we've mastered the connections. It feels like we're done, right? Not yet. The final phase, maybe the most important one, is all about verification. Trust, but verify. So think about it. You've done everything right on the ground. You've followed every step, you trust your work, you trust your crew. But how do you verify all of it before you put a single pound of real load on that system? What's that final critical piece of the puzzle?
The answer is the Boom Simulator software. The best way to think of this is as a digital twin of your entire setup. It takes all the geometry, the equipment specifications, the load cases, and it runs a complete engineering analysis of the whole system before you ever even think about making a lift.
And this is where its real power comes in. The software calculates every single force and torque on that king post. It will raise a big red flag if any component is even getting close to its mechanical limit. It double-checks your whole setup against API industry standards, and it even tells you the correct weights and positions to use for your load test. It is your ultimate digital safety net.
So let's just end with this thought. As a new engineer, it is so easy to think your most important job is about getting data or flowing the well. But I'm telling you, the true measure of a great field engineer is the meticulous, disciplined, sometimes tedious prep work that ensures every single person on that location goes home safe at the end of the day. Master the prep, and the rest will follow. Stay safe out there.